Welcome to this lesson on Helm Charts, where we'll explore how Helm packages applications for Kubernetes. Helm Charts are application packages that bundle everything needed to deploy software on Kubernetes clusters. Think of them as containers for Kubernetes manifests, making deployment simpler and more organized. A Helm chart is a collection of files that describe a related set of Kubernetes resources. It's essentially a package format that bundles multiple YAML manifests together. Instead of managing individual deployment files, service files, and configuration files separately, Helm charts package them all together in one reusable format. This means you can deploy the same application consistently across different environments, making your deployments predictable and repeatable. Every Helm chart follows a standard directory structure. At the top level, you have a folder named after your chart, such as mychart. Inside, there are three key components. First, Chart.yaml contains metadata about your chart, like its name, version, and description. Second, values.yaml holds the default configuration values for your application. Third, the templates directory contains your Kubernetes manifest files, such as deployment.yaml, service.yaml, and ingress.yaml. This structure keeps everything organized and easy to manage. The Chart.yaml file is the heart of your Helm charts identity. It contains essential metadata about your chart. The API version field specifies the chart API version, which is v2 for Helm 3. The name field identifies your chart, while the description provides a brief explanation of what it does. The version field tracks your chart's version using semantic versioning. The app version field indicates the version of the application being deployed. Finally, the maintainers section lists who is responsible for maintaining this chart, including their name and email address. The values.yaml file is where you define default configuration values for your application. Here's where the power of Helm really shines. Instead of hard-coding values in your Kubernetes manifests, you define them here. For example, replica count specifies how many pod replicas to run. Under the image section, you define the container repository, tag, and pull policy. The service section configures how your application is exposed, including the service type and port number. These values can be easily overridden for different environments without modifying the actual template files. Templates are Kubernetes manifest files with placeholders that get replaced with actual values during deployment. Instead of static YAML files, templates use special syntax with double curly braces to reference values. For instance, in a deployment manifest, you might use .values.appName to inject the application name from your values file. Similarly, .values.replicacount pulls the replica count, and .values.image.repository specifies the container image. This templating system makes your manifests flexible and reusable across different configurations and environments. Understanding how Helm processes charts is crucial. The rendering process happens in 3 steps. First, Helm reads your templates, which are YAML files containing placeholders. Second, it combines these templates with values from your values.yaml file or values you provide at install time. Third, Helm generates final Kubernetes manifests with all placeholders replaced by actual values. These rendered manifests are then ready to be deployed to your Kubernetes cluster. This separation of templates and values is what makes Helm charts so powerful and flexible. Helm charts provide 4 major benefits for Kubernetes deployments. First is consistency. You can deploy the same application across development, staging, and production environments with confidence. Second is versioning. Helm tracks all changes to your deployments, making it easy to roll back to previous versions if needed. Third is simplicity. Complex applications with multiple Kubernetes resources can be deployed with a single command. Fourth is customization. You can override default values for different environments without modifying the chart itself. These benefits make Helm an essential tool for managing Kubernetes applications at scale.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.